factoring. The easiest type of factoring is just pulling out a common factor. And that should always be your first step. So, I don't know, say I gave you something like 6x squared plus x. If there's a common factor to take out, you take it out, right? That's always the first thing you do. Is there a common factor? Yes, I can take an x out of this. So I should. If I take an x, what's left? 6x plus 1. Do not forget about that plus 1. When you factor something out, you should be able to multiply it back in and get right back to the original. So it is a very common mistake to just say it's 6x. Well, x times 6x is only 6x squared. Where are you getting the plus x from? You won't unless you have that. Okay? So please do not forget about just taking out a common factor if there is one. Okay? Sometimes that's all you can do. That's all I could do there. If I have a trinomial, like this one, x squared plus, let's say, 9x plus 20. My first step is still to pull out a common factor if there is one, but this time I don't have one, do I? Nope, too bad, so sad. So that's when we start to look at if a is 1. If a is 1, you're almost done. Find factors of c that add up to b. So what are factors of 20 that add to be 9? 5 and 4. If your directions are to factor, you are done. Done. If your directions are to solve the quadratic, first of all, it's going to be an equation. There's going to be an equal 0. That's when you set both of these equal to 0 and you get two answers of -4 and -5. Okay, that's for solving quadratics. If you just have an expression, you are just factoring it.
Where do you put x equals -4 and -5?
Only if you're being asked to solve the quadratic. If you are only factoring, that's all you do, and you are done. You walk away from it. Remember that whole test where I think your answer sheet was boxes, and I kept telling you, whatever's in that box, I should be able to multiply it together and get back to the original. So if you just have -4, -5, well, that's 20. That's not this. These two foiled together get me back to this. Okay, well, that's the easiest type of factoring. Then you might have things like this. What if you saw... Oh, wait. Make that a 6. -3, so... I think that's right. Okay, so I gave you this and I asked you to factor it. What do you do first? You can take out a 2x. You constantly, that's always got to be your first thought. Can I take anything out? Take out a 2x. Now I have x squared minus 3x minus 4. Okay, and now a is 1 again. Hooray! So if a is 1, you're almost done. Find factors of c that add up to b. So what are factors of -4 that add up to be -3?
X minus 4x plus 1.
And then what happens with this 2x? Oops. It just comes down. It's just part of your answer. That's all. Right? So I should be able to multiply all of that back together and get back to the original. That's the whole point of factoring. You're breaking it down into its pieces. So if you're missing that 2x, you're never going to get back to the original. Okay. All right. Now, factoring wasn't always so easy. We had some trickier things. Actually, before we get to something too tricky, what if you had this? Do you remember what to do with that?
Yeah, it's the difference of two squares.
Yeah, so what does it turn into?
X plus 9, x minus 9. Sorry, 3.
Right. When you still look to see if there's a common factor, there isn't one. Then I only have two terms. So you want to ask yourself, is that the difference of two squares? Yeah, it is. That's a perfect square and that's a perfect square. So you break it up into the same two binomials. It's just the square root of each one. Just make one a plus and one a minus. You can always double check yourself by foiling these back together, making sure you really do get back to that, and you will. Okay? So don't get thrown off. I mean, it might look crazy. You could have something like that. At first glance, that looks like nothing to me. I don't know what that is. There's nothing I can factor out of the whole thing. So then I'm like, gosh, I'm supposed to factor this? Oh, these are perfect squares, aren't they? So you can actually do this. What would go in these?
5x to the third.
Yes, 5x to the third is my first one, and then one's a plus, one's a minus, and what's the other one? Yes, 9y to the fifth. Yes. So that is the difference of two perfect squares. Do not get, don't fall into this trap. If you had this, you're like, oh, difference of two perfect squares. Okay, great. So that'd be x, oh wait, sorry, I meant to the fourth. That's x squared plus 4, x squared minus 4. If you give me this answer, you're going to be wrong. Why? This one splits again. This one does not. It's only the difference of two perfect squares, not the sum. So this one just comes down, x squared plus 4. But then that one splits into x plus 2, x minus 2. And now I'm done. So just always be mindful that you factored as much as you possibly can. Okay? Now we need to talk about factoring when a is not 1. All right? Give me a second to come up with one. Because if I just pick random numbers, it might not necessarily work. Okay, let's say, where's my pen? All right. Say I want to factor the following. 2x squared plus 5 minus x minus 15. You're trying to factor this thing. Darn, I can't take a 2 out of the whole thing. That would make my life so much easier. Shoot. What do you do when a is not 1? The t's, exactly.
Or can you do quadratic?
If you're solving a quadratic. But if you're factoring, you can't. All right, so I think those are all my factors. So remember how the t's work. I need to multiply, luckily here we only have one pair, but I'm trying to find a set of these numbers, imagine this list was longer, one set of these matched up with one set of these, so that I can multiply a number from here and a number from here, and then multiply the other pairs, and I'm trying to get them to add up to be a negative 1. Since it's multiplying to be a negative 15, that means someone's got to be negative. So for example, I could do 1 times 15, that's 15, and then 2 times 1 is 2. So even if one of those was negative, if I had negative 15 plus 2, doesn't add to be negative 1. Or negative 2 plus 15 still doesn't add to be negative 1. So that's not my right pairing. So then I try, okay, well, let's see over here. Oh, hey, look, I could do 2 times 3 is 6, and 1 times 5 is 5. So if I just make the 6 negative and the 5 positive, that'll get me to that negative 1 that I wanted. So I like to jot it down for myself. I want a negative 6 and a positive 5. And I circle them once I figure out what I need. So some of you have a block like you got here, but now you don't know how to actually get the factors. So here's how you do it. You make the 2 parentheses. Those 2 numbers are always the first one. So that's going to be x and 2x. Always. Whatever those are. Put them in the first spot. So now I need to get a -6 and a +5. All right, using these two numbers. So I need to do 2 times 3 to get that 6, don't I? -3, really, because I want it to be a -6. Whatever, since I need to multiply him by -3, it has to go in the other set of parentheses. You're never going to put the two that you need to multiply together in the same set, because when you FOIL, you never FOIL the two in the same set of parentheses together. So that means the -3's got to go there, and that means the +5's got to go on this end. If you're bad at it, put it where you think it goes, and then quickly FOIL it back together and see if you get back up to this original. 2x squared plus 5x minus 6x. Yep, that's -x. And then minus 15. Okay, so there you go. That's how you do that. So let me give you one more to try. Try this one. Okay, try and factor that. Okay, do we get it? So I'm trying to get to a -11. So maybe I'm going to multiply. That's not going to work because I could do 24 and 1. Or I can do 12 and 2. That's too bad because 12 and 1 would work, but 12 and 2 doesn't work. Okay, so maybe I do 4 and 6. Nope, that doesn't work. 12 and 2 again. Nope, that doesn't work. Okay. 8 and 3. Oh, yeah, I can get 8 and 3 to 11. They both have to be negative, right? -8 and -3 would add me up to a -11. So -8, -3, and those are the ones that I'm using. So now I set it up. Boom, 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 boom. These two go in the first spots, 3x and 4x. Okay? I need to create, I'm going to put these two numbers in, and I need to get a -8. So that means I need, where am I going to put my -2? Here or here? First spot or second spot?
Second.
Here?
No, second.
Or here?
The other one.
You want to put it here?
Oh, I know. Wait, what
I want to put it here. To get a -8, I need to do 4 times -2, right? So I have to put it in the parenthesis opposite the 4.
I don't know why I said
Oh, that should have been a 2. What am I doing? So there goes my -2, and then I also have to put a 1, and it looks like it's got to be negative to get me -3, right? So I'd put a -1 right there. Those should be your two factors. Again, it's a very easy check. 12x squared, outside's -3, inside -8. Yep, -3 and -8 get me to -11, and then the last -2 times -1 is a +2. So if A is not 1, well, first, always check and see if there's something you can factor out, because maybe you can get it to be 1, and then life's easy. And if not, you go for the T's. All right? And then the only thing we have left to do in this section is Let's just see if anybody remembers how to handle this. What do you do for something like that? Well, step one is always the same. Is there anything I can take out of the whole thing? Too bad, so sad. Okay, great. Now what? Yes, if you have 4 terms. Remember we literally drew the line down the middle and you factor each side? Yeah, so if you have 4 terms. No, because you have 5. Yeah, and the 3. Okay, so if you have 4 terms and there's nothing for you to take out, draw the line and we're going to factor each side. Okay, so what can I take out from the left? 3x squared. What would be left behind? Yes, right? Is that okay, everybody? X minus 2 right there. And then I do the same thing on the right-hand side. What can I take out? 5, and I'm left with, right, and then do you remember what happens now? Yes, so these 2 parentheses should be identical. If they're not, that means that this polynomial can't be factored this way. But I have a feeling if it's on your final, it should be able to be factored like this, right? There are other things you can do, but that's really an Algebra 2 topic. So these 2 should match. That becomes one of your factors. And then what's out in front comes together and makes your other factor. So one of them is 3x squared, and it's a positive 5, so I have plus 5. And then the other one is just x minus 2. So if you were to FOIL these 2 things back together, you really do get right back at this original. Okay? So if you have 4-term polynomial, take out a common factor if there is one, and then draw the line. Okay? So we have a few minutes for you to try some. Grab this packet.